All right, for example 2, if you are comfortable enough and you feel like you want to go ahead and give these a shot on your own, feel free. Take off, write down the work, draw the pictures as it's asking you to. This video goes through D at the bottom of the page. Feel free just to fast forward to the end and see if your answers are right. If they are, skip all of me talking because it will seem like you know what you're doing. Okay, but for those of you again who want the instruction and need it, and that's perfectly fine. Okay, I got to do a balance of between having me wander the room and you kind of wander in your own mind. So here we go. All right, so new scenario. You ready to leave light bulbs behind? The heights of, I'm going to say 20 somethings, are normally distributed with a mean of 69.2 inches, standard deviation of 2.9. Find the probability that a 20 something's height is between 66 and 72 inches. So 66 being, again, right about down there, 72 being right about here. And so we are trying to find, again, this area. When we want to find the area, that's when we use our normal CDF function. And we do have a minimum or a lower boundary that is 66. Our upper boundary is 72, mean of 69.2 inches, standard deviation of 2.9 inches. And so that should give us a probability of 69.79. So about 69.79% of all 20 somethings are between 66 and 72 inches tall. Okay, moving on to question B. Find the probability that the 20 somethings heights are less than 68 inches tall. So again, just kind of estimating 68 inches being right about here and less than, we're finding the area to the left. We are looking for the area. So again, we are back to finding a normal CDF. We want the probability. There is no lower bound, okay? If we've got a 20 something that's super short, that's fine. They get to keep that. So either your negative like 1 million or negative 1e99 is our lower, upper 68 inches, mean 69.2, standard deviation 2.9. And again, just pay attention, since we're talking to the left of 69.2 inches, we should be smaller than 50%. Because at 69.2 on down, we should get 50% of the area. In this case, we find it is 0.3395, or again, there's about a 33.95% chance a 20-something is less than 68 inches tall. Okay, so for C, find the probability a height is more than 70 inches. So again, I'm going to sketch in roughly where that 70 would be. And now since it's more than 70, we're going to the right. So our normal CDF. Lower boundary, lower limit is 70 inches. We don't have an upper boundary. Somebody can be super duper tall. So 1 million or 1e99, mean, standard deviation. And again, this answer should be smaller than 50% because we are definitely above the mean, and I'm getting 0.3913. Okay, and then D, if we randomly pick 500 people in their 20s, how many would we expect to be more than 70 inches tall? So again, from part C, we just found out the probability they're more than 70 inches tall is about 39.13%. So if we find 39.13%, so multiply the decimal form or the probability you just found, we will find about 195.7, again, rounding to the nearest tenth. So we expect, and if you want to say about 196, I'm okay with that. We expect about 196 of every 500 people age 20 to 29 to be more than 70 inches tall. Okay. All right, so that's the end of this video. I encourage you to go ahead and go on to page 9. Try to do as many of those as you can. And the next video will walk you through all of them. Again, if you want to fast forward to the end when you get to that video, check your answers and see how you did. You might be able to skip me talking again.